All right, so here was a problem that was assigned to you. Now, I just sort of shorthanded here the key stuff. So what we want to know is the amount of energy it takes to freeze 5 grams of water that's already at 0 degrees C, which means it's cold enough to start freezing, but the question was saying that it hasn't yet frozen. That's what I explained in class yesterday. It's still a liquid. There's none of it that's started to crystallize. How much energy do we need to freeze? The value I gave you for the enthalpy of fusion is 334 joules per gram. And so the equation we need is, this is the heat exchange, the amount of heat that's being taken out of the water. Okay? So it's got to be a negative number when we're done. Okay? If you're removing energy from the water, the energy in the water is being reduced to make it freeze. Does that make sense? Got to pull energy out to make it freeze. Okay? So you could say negative Q here if you want to. So then the equation is simply the mass times this enthalpy of fusion. Now, if it was delta H B sub B here, that would be for boiling. So that would be what happens when you go through that transition state between liquid and gas for that substance. And every substance has 2 different enthalpies, just like every substance has 3 different specific heats. You have a specific heat for each physical state. You also have an enthalpy for the change for the 2 different state changes, going from solid to liquid, liquid to solid. Either way, it's the same number. And a separate enthalpy going from liquid to gas or gas to liquid. So all we have to do is plug in the values here. I kind of made it really, really simple. We have 5 grams of material, and that particular material, the enthalpy of fusion has, and this is water we're doing here, has an enthalpy of fusion of 334 joules per, 4 joules per gram. And I've taught you to do this. Keep it all nice and straight and simple and everything. Nicely arranged so that we cancel out grams. And the units we're going to have left are joules, and joules measures energy. And this is the energy change. Usually it's heat. Okay? So all we got to do is the math here. So 5.00 times 334, and we get 1670. But this has to be in 3 significant digits. Both these numbers are in 3 significant digits. So we're going to have to underline the last digit, and we're going to have to round off to 3 digits. Now, anytime you have to get rid of a number in the ones place, anytime you have a number has an insignificant digit in the ones place, you must write your answer in scientific notation to show the answer in the correct number, to the correct order of magnitude. So we're going to move the decimal place 1, 2, 3 places. In scientific notation, the decimal place must go between the first and second non-zero digit. Okay, so now we're ready to round this off. 1.67 times 10 to the, we moved it to the left 3 places. 1, 2, 3 places, so it's times 10 to the 3rd power joules. Now that has to be what's happening is this system here is losing energy, so this has to be a negative number. Okay, we're removing negative 1.67 times 10 to the 3rd joules from the water. Okay, what was the original question? How did it ask it? Let me make sure I'm giving you the right. Water. How much energy must be removed? Okay, well, actually you could put in positive because it says how much could be removed. Okay, I'll give you credit for either negative or positive. So it's saying, since the question asked how much would be removed, then you can say that many joules of energy can be removed, and that would be correct to have a positive number. Does that make sense? If I asked you what is the energy change for the water to freeze it all, then it has to be negative. It depends on how the question's wording. So I don't count off for lack of a negative symbol in front of it there. All right. Now, as always, you need to show your equation. Q equals mass, and you don't really have to have the time sign, because if you put mass times this delta H. Oh, sorry. Let's go back to the. Where are we? Okay. So Q equals mass times delta H, and you really should say sub F, but I'm not going to count on for it if you don't have sub F. This time, you need to know, though, you need to list the specific kind of enthalpy function you're looking for, or enthalpy value you're looking for. Is it freezing or boiling? You need to show that, okay? And then you got to say that 5 grams, and you cancel the grams over 1, times this whole value, canceling the grams. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points so far, equals this number of joules, rounded off to this number of joules. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 points I want to give for this one, okay? I said 17? Okay. All right. So I am going to